Well, good morning, and thank you for joining us on this Friday morning. I'm actually coming into the session from the AI Horizons conference here in Pittsburgh, so seems somewhat fitting. My name is Bo Motlug. I am the co-founder and managing partner of United Effects Ventures, and I'm really happy to be kicking this off here. At UEV, we basically do three things. We deploy capital and our resources and time to accelerate B2B origination stage AI companies. We experiment internally and build new AI companies that we spin out. And we invest a lot in community, founders and technologies, and really anybody who wants to build a business. We want to make sure that they're supported. And to that last point, welcome to Control Shift. So this is going to be an ongoing series to explore practical and real technical solutions to drive innovations and rapid acceleration of anything that people want to build. This is not a what if conversation or any of those sort of hyped up conversations. These are going to be real demos, real tutorials, and conversations, practical discussions. And we're kicking things off with a three-part demonstration and conversation on how to build with AI. And again, this isn't a vibe coding thing. This is going to be real enterprise grade processes for technologists to look into. Make sure that you tune into the other sessions for this kickoff. This is, as I said, a three-parter. And you can look at all of the events that we are hosting for this and everything else at UE.ventures. If you go down to events and click all events. Let's see, what am I missing here? Before we kick this off with Nik Patel, who is a multi-time founder, a technologist, and AI advisor at UEV. So very excited to be doing this with him. Just want to give a special thank you to our Chief Marketing Officer, Paula Fontana, who is making the community possible for us and for all of you. So with all of that said, that is my intro, Nick. I will kick this off to you.
Thank you. And yeah, thanks, Paula and Bo. I've been working with Bo for it's been like 12 years now. We have known each other. And I think one thing that's common between Bo and I is having this like technical mindset, yet have gone through this entrepreneurship where we have built companies. And one of the things that we have been chatting about for better part of a year now on how things have been changing and how quickly they have been changing. Every week we look at something, it's like, whoa, this is cool, to like, what does this mean for businesses and whatnot? And more I have this conversation, it generally leads into what does it mean for us as technologists? What does it mean for us as engineers? How do we keep up with this? One thing that's been real, there is a lot of hype around what AI can do. And in the beginning, the hype actually does, play out pretty well. And then you start to go deeper, and all of a sudden, it starts to feel like I'm spending more time on yelling at AI than getting the work done. So um, we have been pretty hands-on trying to build things ourselves with AI, and appreciate everyone joining so we could go through this journey that we have gone through and share with you on what our learning's been. But at the same time, if you have things that you want to chat through, feel free to put them as into chat or questions, and along the way we'll pause and answer questions, talk through it, and whatnot. So let me start by sharing my screen. Okay, everyone can see the screen.
Yep, you're good to go. You're sharing the gamma. You got it.
Yes. Okay. So I do have a deck that we would go through, but instead of just going through deck, we will also do some hands-on. I will be demoing some hands-on items as we go, and we'll be chatting through how AI helps along the way when it comes to coding, but also through the whole software development lifecycle. Before we get into that, real quick about myself. I'm Nik Patel. I'll be the captain on your today's flight. I'm using that reference just because I pride myself in being a pilot and I love to fly. So I think it's a fitting one. It's going to be a journey today. I have co-authored 5 patents, some of them on on AI itself. So been in the industry for quite some time, but also been pretty heavily technical into the world of AI data, software engineering, and for that matter, also into building businesses. Uh, that has given me an opportunity to work with different startups and advise them. So have seen the journey of smaller companies, but also consulting with larger companies on how the processes work there. And today we'll talk about both on what we are seeing on the both sides of the world. Um, when we think about what we are going to go through today, actually before we do that, I did want to call out that this is actually a three-part series that we are going to go through. This is the first of that three-part, and today's goal is to focus on what does it mean to be working with AI, using AI assistant as part of the process on whatever type of work that you are doing. And align ourselves on where we see value, what should we be looking out for, how do we start to get in that rhythm. The second session that I believe is on October 10th will be much more going deeper at an advanced level on some of the AI assistants, including Claude Code and probably a couple more on how do you use those coding assistant to do a better job and making sure that you are getting the quality that you would expect out of the code that it's generating and put that in production, along with some of the security constraints, risk, privacy, whatnot. And then third session would be where we would probably get hands-on together. That will be in November. So for today's agenda, I do want to start with a demo and showcase something that I actually built overnight. And the whole idea was there is a lot of hype around what can be done with AI. Can I do something that I have not done before? And what does it mean for me to do that? And walk through that journey. As we think through that, we will also be looking at anatomy of AI systems. And we will look at those systems and the anatomy of those AI systems and how that applies to different type of systems, regardless of where they specialize. Some of those systems might be for general users. Some of them might be for product people, marketing, engineers, and whatnot, but they all follow similar patterns. From there on, we'll go deeper into agents and how agents are built, what to look out for when you go into agents. Going into coding, what type of new coding paradigms that we are seeing, including spec-driven development, and then going into the whole software development lifecycle, how that's growing, and what sort of changes we are seeing with that as AI continue to be becoming a part of your daily life. Last but not the least, we will end with the future skills and what you should be paying attention to as you start to embed AI into your daily workflows and, for that matter, your life as well. Okay, so let's talk about what I built. It was about 8 hours, call it 8 to 10 hours, a greenfield project. What I wanted to build was a knowledge graph that had this like space nodes where I could like click around and see how things are going for any topic that I search for. So decided to do that. And for what it's worth, if you know me, probably you know that I'm not a person that develop games, but I am interested in the world of physics. So this was like a good way for me to sort of feel this, how every node connects in the space and like, see that floating around and play with it. So it was sort of like a cool idea, built that in about 8 hours. I'll show the demo of it. And we will use that as an anchor point to talk about how do you build something when you don't even know the tag itself. And when I say tag, I'm more focusing on particular type of a stack, framework, and whatnot, not necessarily not knowing tag as you don't know how to code yet. The second thing was focusing on how do we use AI to its best ability, but also as humans, what do we do so that we know the outcomes are going to be better? So let's quickly look at the demo. It's basically a quick search bar where an AI research happens. Think of this as your deep research. It goes through the process of asking like 5 questions internally on 5 whys, and it ends up generating like a full 3D graph. It saves that data, and now that you have a 3D graph that you can play with, you can see what the data looks like and whatnot. So I'll show that real quick. So let's say for now on this one, I'm actually going to go to localhost. As you see, when I go in, it's basically asking what do I want to explore. I was tired of typing every time, so I created some of the options here. Let's say I just want to see how does machine learning work. If you have used any of the ChatGPT type of tool, you have probably heard of a thing called deep research, which is what this is essentially doing behind the scene. And what's going to happen is when I asked for the query, now it's starting to create like this different nodes, right? So you see the red node started to come up, and on the left hand side you see it's starting to fill with a different type of node. Each node has its meaning. I'm seeing some credibility, some of the concepts that it's gathering, and slowly but surely it will continue to grow in size. Instead of needing to wait for it while it does the work, I also have it open on this side, where after a while, it basically ends up creating like 51 different sources. It goes and does the search online, about 289 concepts, and then bring all of that together to see how everything's interconnected. Now, keep in mind, I built that just for fun without having uh, sort of like a production need for it, but something that I found cool. And as you see, like for each of the nodes, there are like different things that it's showing. What I want to talk about here is I have no idea how to actually build with WebGL, which is the technology that it's using to show the physics. But it's not something that I needed to know right off the bat. That said, I did read the documentation, but I did not need to be an expert because I knew what I was looking for, and I know how to read the code that would go ahead and tell me if that's the right code or not. So one of the things that helped is building this and having learnings along the way. So let me go back into the tools that I had used. The first tool that I used was Perplexity. It is something that I have been like forcing myself to use just because I like the experience on Comet browser, which is equivalent of Chrome, with the AI first approach to do some research on WebGL, what it is, whatnot. From there on, I went into a tool called Magic Patterns, which is used to help with prototyping, where I'm not focusing on code, but I'm more focusing on experience. Then I went into Claude Code, where I spent a lot of time. So out of that 8 hours, about 6 to 6.5 hours were spent in Claude Code. And then last one was Vercel, which is where I can deploy this and anyone can play with it. That was the idea. So in terms of human and AI division of labor, what I did as a human was defining the problem, defining the thoughts, requirements on what I really wanted to do, and continuing to iterate on that. Made some architecture decision on stack that I wanted. I had option to go with Python plus TypeScript, but decided to stay in TypeScript altogether for front end and back end, which became Next.js. Reviewed and validated code at each step, which generally takes a longer time, just because I don't want to assume that the code that's being written is right, mainly for security reasons and also knowing what's going on. This AI assistants are notorious in terms of trying to get to the results, where sometimes they would just comment out your code and say, "Oh, it's working," and then when things broke, which they inevitably did, debugging with AI and looking at the logs and whatnot. What AI did was generating the code that I did not know how to generate. This is specifically focused on Three.js, which I know somewhat, but WebGL, which I don't know much. Researched some APIs and libraries. Specifically, in this case, I also used LangGraph. I'm used to using LangGraph in Python, but not so much in TypeScript. But knowing that Python and TypeScript SDKs are probably not that different, I was able to quickly just say, "Hey, go do this," and it figured it out. And then implemented, some 3D graphics that you saw, as well as deployment configuration. All to say, this was done in about a day worth of time, and the the thought here that I really wanted to get across was I was able to move at that speed and was able to trust my code because I know what to look for and have gone through the hard, the old times of like doing stuff myself. So before we go into the next section, I think one of the things that I want to chat through and a little bit get idea from the audience that is joining today is are you what is your role? And I will open up a poll. So if you could answer to the poll, but I want to get a quick idea of the distribution of folks that are joining, so I know how deep to go in tech versus not. So let me start with that. You will see a poll show up. Generally, want to know what is your primary role for whatever you do at work. Okay, I'm seeing about 20% founders, about 36% engineers, 10% product, and then about 36% something else, which is good to know. So we are very distributed today, which is okay. We will talk about regardless of what your job function is, you would probably know what type of tools you could use because we'd go through the whole process ourselves. So that's helpful. Let me share the results with everyone as well. Along with that, I also want to see. Let me actually ask couple more questions. So. Okay. Go ahead, Bo.
Well, it sounded like your mic gave out for a second there.
Oh, yeah, I'm trying to get to polls, but it's not letting me get to the other polls, which is fine for now. But I think one of the things that I wanted to sort of understand is if you have been using any sort of, there you go. The coding assistant, if you were to rate yourself, how would you rate yourself on working with coding assistant and your experience with it? So opening up that poll, if you could quickly answer that. All right, so yes, one person said excellent, so that's great. And rest of it is pretty spread. About 60% of it is essentially saying that, it's okay-ish, versus 40% roughly no idea or not working out. So that's helpful. And then last but not the least, if you had, I'm assuming you have heard of this coding assistants out there. Have you used any of them? And if so, which one is your favorite so far? Right. So we have a tie between GitHub Copilot and Claude Code, which is awesome. There is also two people that have said something else. If you could chat or send a message in the chat on what they are. I'm assuming it's probably Roo Code or Klein or something like that, but still curious about it. Great. So I think that gives me a pretty good idea on the spread of the audience today. So we will not go super deep onto tech today, which is okay, but we will still look at how to make AI work for you and how AI assistant can help you with the work that you are doing. So what I talked about was the great thing I was able to do. But what I should also talk about are the things that was a nightmare to figure out. One of that was actually memory leaks. And I don't know if I still have it, but let me go to developer tools here. If you see the number of errors that I have here, it's craziness. I'm talking about 10,000 errors where this thing's just not able to keep up. A lot of it, when you go deeper, it's because there is a memory leak issue where it's trying to re-render itself as things are changing, and that's what's causing the issue. I had fixed it, but then I rolled it back just to show how bad it gets if you don't really look at the fundamentals of building the systems. The other thing that I think, and let me actually close this because otherwise it will probably make it really hard to do anything with the browser itself. The other thing I think to mention, and that does not come on top of mind for pretty much anyone that is into the world of vibe coding, and I differentiate between vibe coding and AI assisted coding mainly because the whole vibe coding idea is you have a thought and you want to just see what it looks like, but that's not what you end up putting in production. What ends up going in production generally has a human leading the process than an AI leading the process. And as you saw, my my browser is probably going to crash like it did. So that's what happens when we don't pay attention to that. The security gaps are other things. Something as simple as missing input validation that could result into any of the OS 10 security concerns, both from an LLM perspective as well as web perspective. Performance issue, you saw how when I was trying to do a large graph, when I had quite a few thousand nodes, it was not working out well. And these are the type of things where it is really hard to fix them. You can get to this like 80% really quick, but then last 20% takes the 80% of the rest of the 80% of your time. So when I hear software engineers are gonna be extinct and people will not have those jobs
You're
and
like
whatnot,
100% of the trainings.
It becomes pretty clear that people don't understand what it takes to build engineering systems. But at the same time, I think that is also the truth that the systems can be built faster, the coding can be done faster, but the engineering piece of it still takes time. And that's what we would talk about today in terms of where it is better for humans to spend time as engineers. I think we will see that more and more of engineering skills on how to go from prototype to production will become important, and engineers will have to spend more time on that versus just coding. While other folks, well, they can do some coding, but that will not be production ready. And given how the last couple of years have gone, it's probably never say never. However, those things are still continuing to remain true even after what we have seen with pretty smart agents that have come out recently, all the way from Claude Code to now even OpenAI's Codex, which seem to be doing a good job when you put them together. So a human role really becomes identifying these problems when they become a problem, or preferably before that becomes even a problem, and then have AI prompt AI and provide instructions in a way where this solution can be figured out and you can act on them. Because AI, after all, does not know the edge cases and error handling. It would know the basic error handling if you prompted it properly and if you had some lint checks on it. It does not understand the production concerns. And this is a pretty important thing from startups all the way to enterprises on the data governance, AI governance, security policies, compliance. Those type of things are really, really hard to sort of prompt your way out of it. And those are the type of things that matter. The larger the system, the harder it gets. So we'll dive deeper into some of these collaboration patterns into the advanced session, which would be the next session. So we could go much deeper than just brushing over it at a high level. And this is not just a hunch, but even data says this, that we have seen out there from the studies that have been done, where 73% of developers say that they will use AI tool or are using AI tool. About 23% products have some sort of AI workflows built in. But at the same time, many of the projects that go into implementation for AI, about at least 45% of them end up failing in first 6 months. And that is because in the beginning, it's all of this excitement where we see that going to 80%, and the last 20% is where things start to fail and not work out. And then higher churn on the code that is being generated. If anything, AI assistants are over eager coding junior interns. You ask them to do something and they'll just code the hell out of it, even when they don't need to. So what really needs to happen is understand the random AI usage to strategic integration on how you put that into your workflows. And the way I normally think about it is in terms of a collaboration, what humans do best are strategic thinking and business decisions, architecture and system design. This is where understanding how system design works and architecture works is going to be even more important if it's not something you have done already. And then understanding the quality standards. What I mean by that is understanding what you're building and why you're building it defines your quality. There are times where if I'm building something just to test something out where I know it's a throwaway code, it's going to have a different quality standard than something I'm going to put in front of my, tens of thousands of users when the feature goes out. Those have different quality standards. But if you were to ask your coding assistant to create a plan for you, it's probably going to make it the most complex possible because it always thinks that it's going to production and it needs to support millions of users. Not true for all cases. Humans are the best to make those decisions on to what extent we want to push it or not push it. And then last but not the least, problem decomposition. While you could use a reasoning model to do this, nothing beats a human's ability to decompose some of those problems. And better yet, once you decompose them, you also know to what to delegate to AI and to what extent to rely on AI. So that's something humans do pretty good. But at the same time, what AI does best is implementation of known patterns. You ask it to, create some boilerplate code, it's absolutely going to do a great job at it. You ask it to go in and say, hey, create a factory pattern for me and create four different one interface and four different implementation of it. It does do a good job at it, given you have given it good instructions. In terms of doing some research and information synthesis, it does a good job at it. I think deep research is a good example of that in ChatGPT, and others have similar modes like thinking mode or extra thinking mode on Cloud or Claude, and then same on Perplexity and equivalent on Gemini for Google as well. As for code generation and testing, I think this is something that we are starting to see more and more, where AI does a pretty good job at testing. I still remember the days where, from engineering perspective, we were pushing for test-driven development, but we were also always running against the timelines and deadlines, so we could not actually do everything to the level we wanted to do it. AI does a pretty good job at that, both for documentation as well as testing, so that you can be assured that you are at least hitting all the criteria you want to. It still doesn't change the fact that you should be looking at the tests themselves, but at least it helps you go faster and still be more reliable without messing up some of the critical business logic you would need to. Last but not the least, this is not only related to any sort of coding, but anything that you have repetitive task for. Generally, you could set up a good prompt and continue to use that as a mechanism for you to get the answers that you would expect in a way you would expect. It all comes out to figuring out the right task that goes to the right system. Let me pause here for a second. We talked about a lot in terms of going from demo all the way to what the concerns are and what the problems are. So before we get into solutions of it, AI patterns and anatomy of AI systems, I want to open it up to see if there are any comments, questions, concerns, experience that you would want to share.
It's a quiet bunch.
It's okay to be the first one to asking something. Okay.
I guess maybe
Okay.
if I'm just getting, I understand there'll be some like technical coverage in future months, but for people who are just getting started, like going from the I ask questions into like an AI chat interface to like moving more towards assistance, is there a tutorial or anything you recommend starting with?
Yes, there are. I can also recommend some courses, but we will go through that in practice today. Where I want to sort of like quickly go through what that would look like from going from idea all the way to like starting the
Cool.
code and
Thank you.
whatnot. So we will do that. But yeah, if it still doesn't answer some questions at the end, happy to provide resources that are worth checking out. Right? Okay. So let's actually start getting into that itself. I think one of the things that's worth understanding is how some of these AI systems are built, and what sort of decision making goes behind the scene. Now, every system that is out there has its own specialty quirks. Something works, something does not work. However, from a process perspective and pattern perspective, there is a pattern that most of them follow, regardless of if it's a coding assistant or not. And that's what I really want to focus on in this section, where we go through different type of systems where we see it in action, and see how all of them are following that similar pattern. So if you are evaluating a system, you come across a new system, you know how to start working with it and seeing how good it can get in almost no amount of time. The way it normally goes is, then this is a universal pattern, right? You provide an input. There is generally an intent clarification. It, it does not mean that it would happen by asking some questions back to user. It could happen on its own behind the scene, or it could be a question that get asked to the user where user actually clarifies the intent, and then you go on from there. Once that happens, there is a goal setting, which is what sort of outcome do we want? What is the user asking for? What do I need to do? Stuff like that. From there on, some tasks get created and they get distributed for different, call it sub-agents to do. And this is where delegate and orchestrate process comes in, which is, okay, we have 7 tasks to do. Do we do them in sequential fashion? Do we do them in parallel ways? How do we do it? Once that happens, AI would verify the output to its best ability, which may not be perfect either, but it does try to do that. And at the end, bring everything together and respond to a user, or just keep going in that process till you're done with the task. This process generally remains same for anything that is considered AI first system, and not necessarily just like a chatbot within a existing system and whatnot. Even for that, it could be like that, but anything that is considered AI native systems or AI agentic systems, this is a similar process that happens. So when you think about this, what human provides here is an input, and then validates the output that comes out of it. And depending on how big of the process that you're dealing with, either you would get an assistant at each stage, or you would just essentially have AI do the whole thing, come back, and then you start the process again, and you just keep going on in loop pretty much forever. So that's a universal system pattern that we have seen. And the reason I mentioned that is, sorry about all the coughing. It feels like there's something stuck in the throat. So in the case of system that you're working with, we could start from something as well known as ChatGPT, all the way to pretty specialized tools in certain categories, and we would see that all of them follow similar pattern. And I'll show you what that looks like in a second. We could actually test that out ourselves and see what that would mean. So the first one that I want to look at, actually, even before we go into the magic patterns, the first one that I want to sort of look at, I think, Matthew, you asked the question, is how do we go from that chatbot all the way to something else? I'm not sure if everyone has used ChatGPT. I assume at this point you have at least come across it, if not used it altogether. In ChatGPT, there are different options that you would see, right? There are connectors that is pretty recent. MCP has come up recently. Web search is out there as well. And one of the mode is called deep research. Deep research in particular follows the format that I mentioned. This is the intent clarification all the way to goal setting and whatnot. If I were to go and ask and say, I am creating a presentation for AI assisted coding, please tell me the impact of it. The first thing it will do is it will ask me some questions back, which is that intent clarification. What it's doing is it's trying to bring some focus into the work that we are trying to do, right? So in here, if I go in and simply say, all right, well, I'm looking for this to be mixed audience. How do I want to focus on this? Let's just say all of it. For now, I'll make it harder for AI. So as soon as this happens, what you would see is that it's starting the process of research, but behind the scene, there is a thinking process that happened. And that process is very similar to the process that goes into this goal setting on what we are looking to do and how we are looking to do it, right? So it would start to do that, do some work, and then you can see all the activities that are happening and whatnot. So that's one option. If I were to do the same thing in Perplexity itself, Perplexity has a similar thing called research mode, or for that matter, labs, and then like quick options as well. I think one quick tidbit on using that versus using Perplexity is because I could create my own shortcuts for Perplexity where I could do different things like, hey, prep me on a certain meeting that I have coming up, or teach me how to do certain things, or evaluate this deal. The prep next meeting is the command that I have created for myself. And what this does is it helps me provide instructions to the systems so that when the answers come up, they come up in a format that I care about. So we'll let the work happen here. But what I do want to mention is behind the scene, it is going through that process of task setting and goal setting, creating the task, doing all the research. For deep research, it's all about go on web and figure out what's going on, read through that, and then synthesize all the information and create a gigantic report for me. So that's one way to do that, right? And it doesn't have to be just chat. It could be anything that offers that thinking or research mode. It would be the similar process. So now let's say you are I was building that thing, right? The Knowledge Explorer. And the first thing I did was did some research on what should I be using, why it makes sense, what stack I do, and stuff like that. That was for me in Perplexity. Then I went into this mode of prototyping, which was more focused on I want to think through what my UI could look like. Now, in an ideal world, or more so non-ideal world, I could also go into ChatGPT and do the same thing. Hey, go and build this thing for me. Go build some prototypes. While it can do it, it's not built for it. So there are some limitations and there are some frustrations. You start to get a little bit more advanced and it just doesn't work. That's where I have sort of like started to branch out myself into choosing the right tool for the right job. There are quite a few tools out there for people that wants to just quickly build stuff. Replit and Lovable are good sources. But if you're mainly focused on the world of prototyping, UI, UX designs, and things like that, I have found that there is a tool called Magic Patterns, which does a pretty good job. Let me show you what that looks like. In this case, I'll just walk you through what I had done. So I had created this product mission, which basically was I want to build this. These are my primary customers. These are my user personas. This was the research work that I had done and used that with spec-driven development as well. From there on, created what what the problem was, what we want to do that would differentiate us. Similar things that a product person would do, right? They would go look at it and say, why does this make sense? What do we want to do with it? Why are we building what we are building? What value would it bring to us? Like things like that. Some core features that it would have, features that we want to build along the way. So I gave it, all I did was, hey, here's my product spec, start building. In a more serious work, this was more of a true, like, doing it for fun type of a project. But let's say if I'm working on something that is that has a business impact, my first go-to is to actually go on a whiteboard and draw it out myself before I go to any AI systems. So in this case, what I did was I just went into Product Mission and simply put it in and said, go build it for me. As you're seeing here, I have gone through about 6 different versions of it. If I look at the first version actually ended up building a marketing website for me. This is a website that I would put out for someone to see on what it is and how this provides value and stuff like that. It did not understand what I was looking for. So then when I went in and simply said, I want the actual system, not the marketing website, right? And then starting V2, it created systems that were more like what a user would use. So in this case, what happened was it built some stuff. I liked it. There were some changes that I wanted to do. And then I went through about 6 different iterations. And even then, this is not exactly what I ended up building, because I went into the build process. It made sense to make things a little bit different, but at least I had an idea what I wanted to build. As a product person, it is much easier for product person to be able to like prototype with this. This used to take a long time, but now they can do this. And with Magic Patterns, the reason I like it pretty well is I could connect it to our GitHub, and then all the work that happens goes into source control that engineers can look at. It can follow our storybooks and our design patterns and things like that, which makes life a little bit easier. So that's my prototyping process. Very high level, what happened here is I created a design prompt. The intent itself, it did not ask me. It just assumed that it knew what it needed to do. And on the first one, it ended up creating the marketing website. It created some UI goals for itself, created some component task, built the components, generated code, made sure that it works. And the verification for this particular tool is to ensure that the thing renders and builds properly and whatnot. Behind the scene, it is using React or Shared CN, Tailwind CSS, the front-end tool that you would normally use. So it did that and then provided output. My input, obviously, it's not this simple of like go building a component. The better input I could provide, the better output I would have as well. But from an AI perspective, my focus was to ensure that I'm getting what I would expect and then iterating on it versus building it myself. And this is becoming, and you would see that this is becoming a pattern now, where as a human, you spend time on critical thinking, while AI does spend time on execution and whatnot. So there is that. Now, high level, we talked about Perplexity. If I were to go look at that, very similar process again, right? Or ChatGPT for that matter, it would go ahead and do the similar stuff where there's a search intent. ChatGPT asked us about it, some knowledge goals, and it's still going and doing the research, but it's following the similar process up here. And then at the end, it would verify that and just give me like a full report, but following similar process. If I think about Claude Code, which is much more into the world of AI coding assistants, if you have used Claude Code, or for that matter, any of the coding assistants, they follow similar processes as well. You put in a request, it would try to look at different contexts, it would figure out what it needs to do, create a to-do list out of it, generate some code, hopefully test it, and then provide a solution to you. Now, why does this matter in terms of a collaboration? Is because as a human, it is important for us to understand what AI tool to use and when to use it to get the best outcome that we are looking for. And there is no one tool that does all the work, which is pretty expected at this point. And the way landscape is changing, every week there is a new tool, and they just like keep flip-flopping. The leaders keep changing, but I think top 3 or top 5 are pretty consistent now. The value of human still remains. We are the one deciding what happens and why it happens, while the AI does how it happens with guidance. In terms of work that needs to happen in collaborating or integrating our workflows into each other, it is important for us to understand what works better and when, not for AI. And when we know how can we orchestrate multiple AI systems, we generally come out with a better outcome than we would otherwise if we were only using one system. I'm going to pause here for a second, see if there are any comments, questions, concerns. Right. So we want to, since we're talking about this agents, let's continue to go deeper into, we talked about how the systems do the work, but I was mentioning, each of those systems are built of one or multiple agents. Generally, the larger systems have multiple agents behind the scene called multi-agent systems. If you were to look at one agent, what agent normally does is similar process, but at a much smaller scale. It would take an instruction, would have some sort of decision-making power or reasoning power. It would use tools. Now, these tools could be, calls to external systems, could be something called a model context protocol as an MCP, equivalent of calling different type of APIs or external systems that LLM would call when it makes sense. For example, if you were to say, hey, what's the weather right now? Large language model would not know because the training was done, year or two ago. You're asking for weather today. It would not have any idea what it means. So it would normally use a tool called datetime to figure out what today's date is, and then call some sort of API directly or using an MCP protocol to get the weather information, synthesize that information in a human language again, and report back. That's very simpler version of it, but even for complex version, the process still remains the same. Right? Now, what is an AI agent? Something that has an agency, something that learns from the actions that's been taken, and it can take actions versus just responding to a question that you ask. I see Brett, you unmuted. Had a question?
I accidentally unmuted. Sorry.
No worries.
Hey, Nick.
Great.
Just to call out on the tooling, worth mentioning that we're also seeing agents that can quickly script something as part of that tooling if it doesn't have a direct MCP connection to answer the question as well.
Yep, absolutely. Okay, so we talked about the anatomy of agent, right? Like what happens in terms of how the components come together. But there are also different things that makes it an agent. One of the thing we talked about tool execution, which is on the left-hand side bottom. We talked about tool selection a little bit, which is if I want an answer, if LLM is asked a question or is given a task, it would figure out if it can do it based on the knowledge it has. If not, it would identify something called tool, which is like just an instruction that tells it how to like call an external system, and go ahead and either select a tool and call the tool, or continue to go through the reasoning process on, do I have the answers that I want? Does it make sense? Do I need to do more? Agents also may have something called action orchestration. These are the type of agents that would be responsible for, instead of doing the work, they're sort of acting as a manager agent, where they would be delegating tasks to other agents and wait for the responses to come back to make a decision. And they don't have to be just manager agents, but something that that is pretty common in terms of the processes. A simpler way to think about it is we are starting to see that the multi-agent systems are starting to mimic the organizations, human organizations, like a particular company, and how the companies have departments. They have teams and pods and leads and managers and on and on. They're starting to follow similar patterns to be able to mimic the work that humans do and automate some of that. In all of this, the hardest part are context engineering and feedback loop. To go a little bit more into context engineering, think of this as a memory that agent has when it's performing a task. Because large language models themselves are trained, and then the training itself is complete. After training, every time you invoke an agent or you start a new chat, you probably have noticed that it does not remember anything else from before. Some of the new features that have come out both on ChatGPT and Claude tries to work around it by creating like stored memory, but the LLM itself does not have the understanding of what happened. A good example and that I liked, that I believe Dharmesh Shah in his latest keynote talked about, was it's LLMs are like the hero from Memento. If you have not seen the movie, go watch it. But basically, that person has a short-term memory. He loses the memory after some time, and then he started to write down like notes. So every time he loses a memory and comes back, he would look at the notes to figure out what he had done before. LLMs are very similar to that. They just don't know anything. You could create this quote unquote notes and store them in database. And then when you ask a question, they could read up on it, get some more memory into their mind, and then from there on, they would do the task. That generation and management of memory is what's called context. And context has a limited window size. It used to be very limited. Now it could go all the way up to about 1 million tokens. Token is about 3/4 of a word. But high level, it could go up to 1 million tokens, which means you could probably put like 1 or 2 books worth of data in it. That's a good thing, but that's still nowhere close to what humans are able to keep up in their brain. So we are seeing that the intelligence, quote unquote intelligence, that we hear from LLM can go as good as what some of this, what context it has when it's doing the task. The reason I mention that is, as you start to work with AI assistants and specifically coding assistant, you really want to pay attention to the context that is being used and what it has in its context. Most of the tools out there actually tells you how much context is being used, or if you're running out of the context. If they don't tell you that, what they do behind the scene is they would, once they get to a certain point, let's say they have about 1 million token memory, and you have been going on forever, after they get to a point where they run out of that memory, they would just compress that by summarizing everything and then free up some space. So you would notice that LLMs generally have a recency bias like humans do, but also from a perspective of work that they do, they only have certain pieces of information. So the more you can do in terms of providing the right amount of information with the right context, the better your responses would be. And again, we'll talk more about this on how do you create that, how do you do that with Claude MD or other files in next session when we go much, much deeper. But I think it is important to understand that regardless of coding assistant, this applies to any AI system you're working with. If you're a developer or an engineer that is building systems that works with LLM, it is still important for you to know what sort of context you are setting for a particular task, because your responses are going to be as good as the context is and the knowledge of the LLM itself. So last but not the least, an agent in a pure form is something that can learn from the outcomes that it had from before. Now, in a tech terms, it gets a little bit more complex than that, because like I was mentioning, they can't keep up everything that they have learned in their memory at all times. So as engineers, we have to make sure that we set up different type of patterns so that we can store that learning somewhere and choose the right learning at the right time. The other thing that we are starting to see, and this will be a big thing for anyone that cares about the world of engineering and what needs to happen in engineering, what you learn and whatnot, something called evaluations, which is when the LLM responds back, you evaluate the response and you basically compare it against something that you know is considered ground truth. So you can rely on those responses and you're not just hoping for the best. It's a skill that is worth developing. We would not have time to go into it today, but in the next session or the third session, we would definitely go into how to build evals, how to do it so that you can put something in production and rely on the responses that comes back from LLM, where it's not just a hope that everything's going to work out and the responses would be good. So thinking about the context itself, in the world of coding assistants, there are different type of context. There is a context that you set at the project level. Normally what happens is when you start the coding assistant, like Claude Code, you would go and start the code. It would take a particular file at the project context level, and it would put that as a default prompt so that it would, before it start providing answers, it would know what to expect and how to behave. I do have that open as sort of like Claude Code up here for the code that I showed. This is that. In this case, generally, when you set up that project level context, what you're setting is why does this project exist? What is the architecture of it? How are you setting up different type of folder structure? What folder structure would have done? How do you want to do the coding? Where the configurations are set up, what it can do, what it cannot do, how the environment would be set up in which you would sandbox environment, local running, how would you do that? Things like that. So these are instructions of your best practices on how you want a coding assistant to behave in certain fashion and follow those practices. The better this is, the better your assistant would actually behave. And I believe it happened yesterday, but Langchain actually came out with a blog where they did the research on what provides better results and outcomes when you work with coding assistant. And one of the thing was your Claude Code or Claude.md file, which is essentially setting that project context, is highly important and also responsible for good or bad outcomes. You could also do some of these things at like a folder level and based on some previous interactions and whatnot. So for example, let's say you are doing some task and then you had to go away, you come back or something happened. You could like restart that conversation where it would take all the context from before, dump it in, and then start the process. All to say, the better the context, the better the performance. When it comes to tool selection, generally, the type of tools that you want to give access to in terms of coding assistant, file operations, definitely be careful about what type of file you let it access. Generally, I stay away from allowing access to .environment files or .secrets or equivalent of whatever technology you are using. For Python and TypeScript, it's .env files. For .NET stack, it's generally secrets.json and whatnot. Essentially, anything that is considered sensitive information, you do not want coding assistant to be looking at that for many reasons. But for a fact that once it has access, you don't know what it's doing behind the scene, and that's what leads to all sorts of problems down the road where you don't even know when it happened. The one thing that I'm generally pretty adamant about is having some sort of a Git access. Either do I allow for automatic commits, automatic PR and whatnot is a different story. But having a Git integration makes life easy because it could create that source control and history that I could go back to and revert back to when I know things are not going right. A very simple rule of thumb to remember is if you try, let's say you are asking coding assistant to do something and you get to a point where it's just not getting it done, after about 3 to 4 tries, it's better to just start a new session instead of trying to continuing to make it better and better, for 2 reasons. One, because your context is already there and it's just sort of like messing things up, regardless of how good you try to make it. Once it goes off path, after 3 or 4 tries, just start a new session. There is an actual white paper with a study on how that works from a mathematical perspective, but I'm not going to bore you with that today. In terms of package managers, testing frameworks, and deployment tools, these are type of tools that you could offer. It's up to you and based on the sensitivity of the work that you're doing on how much you want to allow for that. That said, the truth remains, the more tools that you offer to agents, the more situations it can handle. However, more tools means you have to provide more information on what each of those tools will be supposed to do, capable of doing. And because of that, you are going to eat up some of the context. So it's a fine balance. It's more of an art than a science, right? And when it comes to the agent itself and orchestrating that, this is where it starts to get really advanced, where you figure out in which order do you want to execute things, how do you want to handle the dependencies, what do you want to do once the task is done. For example, once your coding assistant or Claude Code, or for that matter, any coding assistant finishes a task, I have some hooks that I have created where it would run a lint and run a test and things like that. But I would know that it's doing its thing right before it moves on to the next one. There is also parallel operations. You could run multiple instances of this coding assistant side by side. I think in many cases it's okay, but if you are going to do that, it's better to use something called a work tree. Git work tree is a concept that lets you do things in parallel without messing up the code and being able to revert if something were to go wrong. And then failure recovery. This is more about building the orchestration than doing the orchestration, but it's any system you're building, it's matter of when the system will fail, not if it will fail. So it's always better to prepare for it and build for it, and then coordinating between different tools. So if you have a tool that is doing one job and then other tool chain needs to happen, like you'll be chaining the tools, it's better to sort of be explicit about it than hoping that LLM will figure it out. After all, in terms of feedback, what generally happens is you would refine, you would track what's going on, you would adapt to the work that's happening, and in many cases you use Claude MD file or Cursor MD or GitHub Copilot MD. That all of the coding assistant has something around that. You would use that, make sure that you tell what your best practices are at a team level, company level, personal level, whatever. You would refine the work that it's doing, and I'm pretty adamant and also pretty particular about if there are certain things that I know coding assistant is just simply not understanding, I continue to refine and update my Claude MD files, and for that matter, other agents too. I'll give you examples of something that I like to do at this point. Anytime I'm asking coding assistant to run tests for me or confirm that the tests are working and whatnot, I have strict instructions on you have to use the virtual environment I have created specifically in the world of Python. You have to use it in this format. You have to use these tools, and you have to follow these processes so that I know that you're not going to mess up. Otherwise, what it ends up doing is it would try to do something and say, oh, that didn't work. Let me go and create a simpler version of it. And now you have 2 files, and it just starts to create a mess in your code base, which becomes a maintenance nightmare. And then last but not the least, Also give it reward on if it's doing something well, write it down and have it continue to double down on it. All to say, the more you work with it, the better you know how it's working, and then you can give instructions in such a way that it will continue to get better on its own. If it's not a coding assistant where you are like heavily involved in some of the systems that are out there, pretty much all of the systems that are out there offers a way for you to provide this type of approach. So for example, going back to ChatGPT, let's say you're not using any coding assistant. If you were to go into your account and you go into your settings, in the personalization, you can see different type of memories that are getting set up. You could also set up different type of security, different controls on what you will allow for, what you would not allow for. And then last but not the least, you could set different type of, and for some reason I'm not where that would be right now. But it would essentially be going into something like this, where you would set up your own on memory on how you want ChatGPT to respond, how you want it to work, things like that. If you have not used this, you could also use different type of projects, where in the project settings you could actually create you could add different files and make sure that they are available, and you could set like particular prompts. Same goes for Claude and whatnot. Doing that and creating that sort of like spaces helps them make sure that they can stay focused, and you don't have to keep saying the same thing over and over and over. Okay. Before we go into this, I want to take a pause again to see if there is anything that I can answer, any questions or comments, concerns, experience you want to share.
I'll share like one thing. So like I do something very similar where I'll create a project and I'll have like that .md file, right? Like the Claude MD, and I'll state like some rules. I've made quite a few different projects for different things, like, like Java, creating like multi-module or specific setup instructions to try to see how the AI would actually generate the project. And I've noticed that with larger types of like auto generation, it tends to keep breaking the rules. I have to keep reminding it, hey, go back and look again, you're breaking it. And then it'll eventually get there. But I found like the more that the AI has to do, the more likely it is to make a mistake.
Extremely, you're absolutely right. And I'm not Claude Code myself, but Claude Code does say that. So now I'm used to saying it too. But yes, that does happen. And I think two ways to work through it. One is your Claude MD files or your instructions files in the beginning. But second, there is a concept of like post hooks or hooks in general, but pre-hooks and post hook, where you could set up shell scripts and force it to do it with the programming versus doing it with LLM. And there are reasons to do it, specifically if it's like lint type of thing where you are expecting it to follow certain practices and it's not. With lint, you can force it, and you could mark it so that the lint would fail. And when the lint fails, generally LLM would pick it up much faster than hoping that they would pick it up from natural language instructions. Hopefully that helps. But thanks for sharing.
Yeah, thank you.
Okay. So I think I did want to talk about this. Again, we will probably not go into too many details today. But if you have been in the industry, I'm sure you have heard taste-driven development, the behavior-driven development, and some other types. One of the things that we are starting to see, and this is on the rise right now, is called spec-driven development. It is more following that process of without coding assistant. It used to be product team and engineering teams that would sort of like work together. Product team would create a spec and give it to engineering team. Engineering team would do the work, and on and on. In this case, because we are giving instructions to system, specifically LLMs, the spec-driven development has been more reliable because it forces you up front to focus on what you want to do, and then continue to refine it and validate and verify along the way to ensure that you're getting better outcomes. Again, we will not talk about, we won't go into too many details today, but just to confirm that this is a thing that does happen and it's pretty important. Let me just walk you through what spec-driven development looks like. So normally with a traditional development, we would get some sort of a spec, Jira tickets, whatever, and you would start with the development. In this case, instead of starting with that, what you would want to do is you would want to start with specification. Now, specification doesn't have to be the whole product level thing. It can be anything, which could be I want to build a feature, I want to fix a bug, I want to make sure that this particular test passes moving forward. Normally, it is at a little higher level at a feature or bug, and not necessarily exact task. But you would do that, and you would work with the systems to be able to make sure that you have gotten your instructions right. And spec-driven development, there are some tools out there that does a good job in converting your instructions into something that are more reliable and better prompts for coding assistant that can be enforced. So the first portion of that requirement specification happens by human. In this case, it doesn't have to be just non-technical people. Even as a technical person, I prefer to do that because I know I could provide much better engineering-based instructions where I know LLM would do a better job than simply asking it to do something and then hoping that it does it. So going back to what Brett was saying, if you give it too big of a task, it most certainly will hallucinate or fail to achieve that. But having spec that can be converted into tasks, that can be converted into subtask, and focusing on that subtask as an execution generally helps a lot. When you do the spec, you also think about technical design. So this is where having that understanding of engineering principles come pretty handy. You would essentially figure out what type of libraries make sense. And this is where you are doing a pre-research, and it can happen with LLMs too, but you are doing the research and making a decision before the execution starts. Your architecture patterns, your stack, your libraries, your testing methodologies, your debugging methodologies, things like that. Then you would plan the implementation. What is the order of implementation in which you want to go ahead and execute these tasks? Then the code generation happens. This is highly done by AI assistants. And at the end, you review and validate the work, which is generally human-led. All to say, the clearer your specs, the better your AI would do. So in terms of, let me actually pause here for a second, but I do have a little bit more on what that looks like. In terms of who does the work when it comes to the interface, who does the work, it would be essentially human who is defining what we need to do. Then AI does some work on how can we do it, not necessarily how would I do it. You use that how you get that information and decide how you want AI to perform. And then that's where you decide the which portion, which is which architecture and technology to use. Those steps are heavily human driven, and that's a good thing. Sort of like, think about that waterfall technologies or methodologies from early 80s and 90s. It is in a very smaller version of that. And then once you are done with those 3 steps, that's when I think you go pretty AI first and AI heavy, where you let AI generate the code, you continue to verify along the way, and at the end you review the work and see what sort of work has come out. This process works 10 times better than it would if you were to just go ahead and give it a prompt. Your prompt could be really good, don't get me wrong, but those prompts alone does not do as good of a job as following this sort of a technology. There are, in terms of the difference between what we have seen between spec-driven versus traditional development, it's traditional development, you write the code first and you document things later. In this, you reverse it. You document everything as much as possible. You define your what, you define your why, how you want to do things. You document all of it before you get into code. Generally, specs are an afterthought, and this is subjective in many cases. It's not, but it's seen as a guideline versus a requirement. For spec driven, it is a requirement. In the case with traditional development, AI gets very minimal context, while with spec driven, that's really your goal, to get as much context as possible. Inconsistent if you were to use traditional AI versus very consistent if you were to use spec driven. Let me pause here for a second, see if there are any questions. Awesome.
Sorry, I've got just one addition to this.
Go ahead.
I find that the specs created by Claude Code in particular are quite ambitious. Months
Yes.
and months of work by a full team. We can achieve this by the end of the quarter. It often does more rather than less than what I want it to do. And that's where trimming it down, whether you just delete things from the spec or you ask it to pare it back, just do phase one, do minimal, stop over engineering. That's the constant that I have to keep doing for these, because it wants to build everything. And so none of the timelines that it provides, like week 1 through 3, week 4 through 7, none of those are realistic, but they tend to give the scope of what it's trying to do. Whenever I see a double-digit week, I say, pause, this is crazy. What are we doing? And then we need to scope it back. So it's often, it can come up with good ideas, but it will do way too much. And so building that spec, starting with the minimal and then stripping it back to the basics is a very good pause point to your point of building the spec, reviewing it, and you're going to save so much more time down the line rather than trying to reel it back in from an overambitious spec.
Yeah, definitely. Actually, I'll take that one step further. I do not rely on any timelines that any of the coding systems or LLM systems that provides out there. Mainly because they have been trained on the timelines that were relevant with the traditional development or without AI assistant development. And normally they say, oh, it's going to take you a few days, few weeks, whatnot. And then next thing you know, you give it a good instructions, and generally it can get it done within hours. Not to say it's right or wrong or anything. I don't want to get into that, but the speed at which things happen today versus the speed at which LLM thinks it would happen are just not aligned whatsoever. Never rely on timelines.
Those are the timelines I give the executives, and then I can over deliver.
There you go. You have cracked the code. Awesome. So I do want to talk about two different frameworks that do a pretty good job at the spec-driven development. There are others too. AgentOS is something that has been, sort of like rising when it comes to spec-driven development. And initially, primarily, it was built for Claude Code. I believe it still works with others, but it's built with Claude Code in mind. Very similar process. It does the specs, creates the tasks, subtask, tech stack, some decisions and things like that. And it has some built-in orchestration patterns, which are essentially instructions on how you would do the work and how you would develop. Then there is the other one that is extremely recent called GitHub Spec Kit. It's called Spec Kit, but it's basically by GitHub. So if I were to, let me just quickly go to Spec Kit. This is something that GitHub, I believe, put out a couple of weeks ago, if not more. And already it's got about 15,000 or 16,000 stars. It is built to work with any coding assistant out there, primarily all the big three that you would consider. Claude Code, GitHub Copilot, as well as the um, OpenAI Codex. It works with all three, and it does do a pretty good job at that. The process that it's following is extremely similar, right? So in this case, you're seeing like it's basically talking about these three names, but it follows the similar process of create the spec, create the features, sub-spec, plan it, and create tasks out of it, and then go ahead and like execute those tasks. So that process is pretty similar. If you are not bought into Claude Code itself, GitHub Spec Kit is pretty good because it is agnostic and works pretty reliably, and it makes it easy for you to switch between different type of coding assistant. For me, it's been appealing to me mainly because when I'm in my VS Code, and there are times where I'm tired of Claude Code not doing the thing that I expect out of it, I would go to GitHub Copilot and have it do some stuff, or I would actually go to Codex now, especially with GPT-5 thinking. Codex has been doing pretty good job on things that Claude Code does not. So, and this is coming from experience of the demo that I was showing, where Claude just simply could not figure out some of the things that I needed to. One of them was being how do you properly like render the nodes in 3JS. It just simply could not figure out the way I wanted to, and I switched to Codex. It did a pretty good job, just got it done on a second try, and from there on I went back to Claude Code. All to say, once you know the process, switching between those tools does not become that hard, because all of them follow similar process and have similar styles on how the work gets done. So we may run out of time, so I will quickly skim through that, but you should definitely check out Builder Methods, I believe, who has built AgentOS, and then GitHub Spec Kit, which follows this process of create the standard, create your product, create your spec, convert that into task, plan it out, convert that into task, and then go execute those tasks. In this case, I do want to call out that it's also called intent-driven development, which is why are you building, what are you building, things like that. Call it spec-driven, call it intent-driven, does a similar thing. So in this case, you would specify in the world of Spec Kit, you would plan and you would create tasks. Again, very, very similar process, similar commands, and similar approaches. Okay, pausing here again for a second. Any questions, concerns, comments, feedback, experience, anyone want to share? Okay, so I want to also take a second to sort of go beyond just the coding assistant, and mainly because there is just so much uncertainty in the world of engineering right now, or for that matter, product engineering and world of AI, on what is possible, what can we do, what can we not do, what is worth relying on, what is not worth relying on. If you are an engineer, I'm sure you have been in a situation where the leadership thinks that something can be done because someone else did it, and then you go look at the system and the data is a mess, or you don't have the access to right tools, or whatever the situation may be. You just don't feel like you can get there at the speed your leadership is asking of you. But at the same time, there is also this fear of like, what happens with the skills that we already know, and how should we prepare for it? So this section is all about that. How do we prepare for it? What have we seen before, and how this is just a continuation of other SDLC approaches that we have seen before, and how that has created the world that we live in today. So when we think about the 70s and 90s SDLC, for people that don't know what SDLC is, it's software development lifecycle. Basically, how a software is built, tested, and delivered is the process. That's basically called software development lifecycle. On top of that, there is also called BDLC, business development lifecycle, where software development lifecycle is a subset of it. But for now, let's focus on SDLC. Long ago, it used to be a lot of manual planning, assembly, label coding. The big gigantic server you're seeing used to be like AS400 or mainframe servers, where you did a lot of coding highly manually. It was manual testing. You would create like a floppy disk or CD and put your software on it and ship it and install it, and that's how things worked. Because of that, the development cycles were pretty long. It used to be like 5-10 years, but at its best, it still became like about a year worth of life cycle, where you would say we are going to create a release, and in a year you would have a software. The hard part here was the rate of change. Things changed pretty slowly, and the feedback that we received versus by the time we could actually act on it was pretty time consuming in general. This was the waterfall methodology, and this is where it used to be. We really want to know what we want to build. We really want to know the impact that it's going to have. We really want to create the spec that is extremely detailed before we get into coding. The reason being, if we mess up on the earlier phases, it used to be that the downstream phases would not have the outcome that we would expect out of them. Then came the era of like web, where source control became a thing. It was SVN and Git and some of the other source control that probably no one uses anymore. Git has survived, but some of the other ones no one uses. And the idea here was we wanted to be able to go faster than we would have been otherwise. And it created this economy of faster feedback than what it used to be. Right? Things that used to take years now ended up taking months. And that was because we could rely on a code base. Multiple people could work on it at the same time. There were frameworks that we could rely on. This was the time where like Spring from Java or Ruby on Rails or ASP.NET, Java's jQuery and things like that became a thing, right? And the whole idea was the scale was increasing, the speed was increasing, cost had to go down. And this is the time where we started creating those agile systems. And from the work perspective, it became N-tier architecture or 3-tier architecture, where you had a UI, you had a business logic, and you had a database. And normally everything that was built with this mindset. Because it was done like that, you would essentially be able to make it easy to go ahead and deploy things. So instead of putting that on a CD and a hardware and manually installing it, there were like basic scripts on deploying that to servers. So this was the times where you would deploy to Apache server or IIS and whatnot. That said, compared to the era before, it was much faster than what it used to be, right? Instead of talking 5-10 years or a year, we were talking months now, where the delivery was happening much, much faster. From there on, the scale increased, and now instead of going to tens of thousands of users, it became millions of users. And this is where we also went from only caring about development and servers to DevOps, which is development and operations, where the infrastructure was managed. This was also the time where containerization happened. So Docker became a big thing, and then Kubernetes on top of it became a big thing, so that we could deploy things that scale up and down based on the demand, right? Infrastructure as a code, which is the whole infrastructure became sort of like a code itself that we could rely on. It would go into the technologies that we had before, such as source control and whatnot. This is also the time where security started becoming a big deal. So if here, where it says basic CI, where we built basic CI and consider that a DevOps, this became DevSecOps, right? Where we were also starting to care about development, security, and ops. And we started to care about compliance, data governance, data security, because data was becoming much more important than it used to be. So very high level, what used to take years to build, and everything was manual in 70s and 90s, took months to build in 90s and 2000, took weeks to build in 2000 and 2010s. This is the time where you probably had heard Netflix was doing things where they were like deploying multiple times a day and stuff like that. That was 2010 to 2020. Essentially, the speed of change increased. And now we are living in this world of 2020 where things that used to take years now takes hours. Not to say you just do everything in an hour and you're done, but things that used to take much, much longer is taking much, much shorter, which means we are expected to do more. We are expected to deliver more. We are expected to deliver high quality at a lower cost for a higher scale. But one thing remained constant. Everything that we are doing, we are still building on top of things that had happened before. Cloud's not going away. Source control is not going away. Databases are not going away. Integrations are not going away if you're in enterprise systems. Security still is extremely important. Data governance is still important. And when we start to think about what it takes to put a system in production, those are the type of things that engineers really need to think through versus just a code. I remember the days where on PR we would be arguing around what is the right, pattern to use. Do we go like Sidekick, or do we go or sidecar pattern or factory pattern or adapter pattern and whatnot? Those are still valid, but those are some of the things that you can start to delegate to AI assistant. I think the things that engineers needs to start to think about is how all of these things come together in a reliable way, because ultimately, as engineers, we are responsible for the quality of work that we put out. So when we consider that, what type of things should we expect? No one knows the future, but based on pattern matching or human pattern matching in this case, I do anticipate these things happening. We would go from user intent to deploying a solution. We have already started to see that happen. Lovable, Replit are good examples of that. But if you are keeping up with the latest announcements from ChatGPT and Cloud, they are doing the same thing, right? You could create Cloud artifacts where it would like build things and deploy it right away, and you do not need to worry about anything else. Again, it's not a production system, but at least it can do it. So it's an early indication of things that would probably get automated along the way. We should start to expect that we would be handling more complex requirements. What it means is we need to start thinking about not just engineering, but we also have to work with product teams and business teams and customer teams. And we have to have that mindset so that we can provide better outcomes and not only be confined to the engineering. The reason it matters is the more you know, the better inputs you can provide and better outputs you could get. If anything, some of the time that you probably were spending writing the code yourself is going to go down. So that time can be used for some of this complex requirement on how to do the job. And for that matter, making others more productive too. The other skill to learn is coordinating multiple specialized agents. Like I was showing, I use different tools at different part of the process. And the more you understand how to have them coordinate with each other, how to bring them together so that do the right job at the right time, is where engineering work will go pretty heavy. Because this is the part where it is still really hard for coding assistant to just go in and do the work. Now, the thing to understand with this is learn what are the team preferences and what are the team patterns that we can enforce on the work that AI is doing. For right or wrong, right? It's the work that goes out ultimately has our stamp on it. So we want to make sure that this coding team that we have can essentially follow similar patterns, and we are not creating haywalk in our code bases. And last but not the least, integrating deeply with existing tools. If you have not already, do some work on searching on MCP and how every company is building an MCP. It is a similar pattern to how every company was starting to build APIs when we went to the cloud era. And we will continue to see more and more. So as you start to think about how to architect systems, think about not only API first, but also MCP first, or I guess both of them in parallel, mainly because so far the users used to be either humans or systems that were deterministic. They know what to call and they know what to expect. Now we have this LLM and agentic systems where they will be extremely dynamic and non-deterministic inputs. So we need to be prepared for it, and we need to be able to make sure that we can provide outcomes when those type of systems need to integrate with the systems we have, or vice versa. So with that type of skills to learn, I think this goes without saying, but one thing that you never want to delegate to AI is your thinking. It's it's going to get to a point where it's like, let me just ask it to do something, and then I'll read it and I'll be done. I have been culprit of it myself, and it has been subpar outcome pretty much every single time. Mainly because as much as we feel like LLMs are thinking, they are not. They are still probabilistic machines that are, creating the next best token that they can based on the information and context that they have received. So critical thinking, I think, remains with humans. More so, it remains with humans because humans understand a much more holistic picture than agents would do today, and it's better for us to continue to do that. So the more you go into critical thinking, understand the fundamentals of first principles, game theory, things like that, the better you would get in terms of how to work with this type of systems, and how to provide better outcomes to the business that is employing you, or for that matter, your personal life as well. Something that has helped me, I don't know if this is a skill to learn as much as this has helped me so much, that every time I'm doing something, I tend to create a mind map of how things come together, which is why I ended up building the 3D Knowledge Explorer. And the reason it helps is it simplifies everything that needs to happen without all complexity. But when I need to go into complexity, it makes it easy to go deeper as well. So if you're not used to it, sort of like get into this thought of or practice of creating mind maps, either visualizing them or just writing them down yourself. And it will really, really help you make sure that the systems that you're working with behave the way you would want. And when they don't, you know where to go focus. I think last thing on the first one is the communication. It goes without saying, learn to communicate with humans, but I think also learn to communicate with AI systems. It is something we would do in the next session, where we would go much deeper onto what are those communication patterns, what works when, and how you would communicate with these AI systems. How would you write a prompt with XML format versus a format of goal, task, outcome type of an approach, and what makes sense and when. Process contextualization. What I mean here is, as humans, I think we would have a much better context and can keep much better context than AI would. So the more we understand holistic processes on where we are doing the work right now, and the outcome and impact of our work and the tasks that AI would do or we would do, the better you would do in terms of what makes sense and what to tell AI. And last but not the least, be willing to, or more leaning towards delegating the work that should be done by AI. My rule of thumb is I'm never going to beat LLMs at compute. So if it's a computational heavy task, it is better for LLM to do. If it is a contextual heavy task, it's better for me to do. So continue to focus on what humans do the best, and you'd be fine regardless of how good the AI gets. So the options are, at this point, you just wait and see to what happens with this whole AI world that we are seeing. Some say it's a bubble, some say it's not a bubble. I'd go back to the patterns and SDLC and whatnot. At some point, web was a bubble as well that did burst. It could happen with AI too. There is no doubt about it. If you saw Larry from Oracle all of a sudden became world's richest person because OpenAI, had a contract with him. Yes, it could be a bubble, it could burst. But keep in mind, when web bubble burst, Google came out of that. So there are some things that we are not going back to. So wait and see, I don't think is a good idea. The second option is random adoption. Just hope for the best. You tell AI and say, like, do this, and hope for the best, and yell at it and hope for the best again. Definitely not a good idea. The third option, which I think is a good idea, is strategically understanding how the systems behind the scene work. How do we properly interact with them, and how do we prepare ourselves to interact with them so that we can get the outcomes that we are looking for. Most of the teams are stuck on 1 or 2 right now for XYZ reasons. If you start to focus on 3, I think you'd probably in top 5%, if not. Okay. So what does it mean? Right now, we are seeing this setup where human is in the loop, which ironically is also the name of our next session, Human in the Loop. Idea being human and AI are working, together step by step. I need to do some research. I ask AI to do it. AI gives me the research. I verify that, and I go to next step and on. Right? So we are in this phase of human in the loop. I think pretty soon we will get into this human on the loop, where we would start to delegate certain things to AI altogether, and focus on where things are going wrong. And when things go wrong, we essentially would step in and fix it. And that requires a more holistic understanding of how those systems work. This is equivalent of how assembly lines work. If you are a supervisor on an assembly line, you are generally on the assembly line and you're looking holistically what's going wrong. And then if something breaks, you go fix it and do something with it. In future, we should also expect human about the loop. There are certain things that we just simply won't care about because AI systems have gotten that good at that it's just like a second thought. Just like we don't talk about, do you know how to use internet, or do you know how to use Chrome or Outlook and things like that? You just expect that it works and you know how to do it. We will get to a point where we would be this like human about the loop. People call this as like AI teams, AI workforce, and few other words and names. So it will happen, but I think that still doesn't change the fact that if you go for the skills that we talked about, you would be in a much better spot. And in fact, the companies would pay premium for you to be working for them or working with them. So right now we are in this orchestration world, right, where we are orchestrating between different systems and agents and whatnot. From orchestration, we would essentially at some point get to strategic world. And you might be just focused on technical strategy, and that's okay, or product strategy or holistic strategy, but I think we would get there sooner rather than later. Great. So that was this session. I think we are coming up on time. So next session that we would do on October 10th, this is where we would go heavily into code. We would, I'd focus on how do you work with this coding assistants? How do you set up your Claude MD files? How do you set up your subagents, your hooks, and then different type of MCPs and whatnot? How do you build complex features? So I'll probably take what I have or build a new system, and we'll essentially build a full feature in 2 hours by using coding assistant. That's going to happen in the next session now that we have a high level understanding. We'll understand how to put quality gates that humans can rely on and evaluation systems. And then how can your team adapt that once you put that in place at a team level? What sort of things do you need to think? So I appreciate everyone joining. And we have gone through quite a few things today. And thank you so much for joining. I will stay here if you have any questions. And there is a QR code on the screen for you to sign up for the next session. And I hope